Okay, good morning. This is Professor David J. Delos Reyes. Okay, the date for today is November 22, 2023. The time is it's almost 4 o'clock in the morning. Okay, my topic for this morning will be a continuation of my trigonometry, and we are now on lesson number 27, and the title of the topic is Solution of Trigo Functions. This will be example number 2 on the so-called solution of Trigo functions. Because the next time around, we will be discussing what I call this Trigo functions involving double angles. So for tonight, let's finish the solution of a Trigo function, and this will now be example number 2. Okay, let's proceed. The title of the topic or our lesson for tonight, this morning, will be Trigonometry, lesson number 27, and the title of the topic will be Solution of Trigo function. This is function number 2. The last example from the last lesson is actually Trigo function solution number 1. This is number 2. So this is actually example number 2. Another variation of a problem. Okay, I will try to read the problem. We are given secant square of alpha plus cotangent square of alpha, and it is equal to a value 13/3. The problem is asking what will be the value of alpha. So it seems we are solving the solution of this given trigonometric equation. Like in the so-called study of algebra, we are solving algebraic equation. Under the study of trigonometry, we are solving the solution of a trigonometric equation. It could either be a linear, quadratic, cubic, or to the fourth power maybe. Okay, let's try to bring out the solution of this one. Okay, we start with secant square of alpha. We'll try to convert this secant here and cotangent in terms of a sine function and cosine function. Okay? So secant square is actually 1 over cosine. 1 over secant is cosine. So if this is a square, instead of just simply cosine, it will be 1 over cosine square of alpha. For a cotangent is actually the ratio of a cosine over sine, right? But this is a square. So cotangent square will be a cosine square of alpha over sine square of alpha. Or actually, we could remove the square over here. I will just place here. Sorry for this one. Open and close quantity square, because this is a square. Because cotangent is actually, cotangent square of alpha is just a cotangent of alpha quantity square. And cotangent is actually cosine over sine. But this is square, so we must have to square it also. And this should be equal to 13/3. Okay? Simplifying this one, this will now be, if we try to square this one, this will now be sine square of alpha. This will be cosine square of alpha. We remove the quantity. If we try to simplify the right hand side, or left hand side rather, this is cosine, this is sine square, a different denominator. So we use the butterfly method. It should be the simplification of the left hand side will be 1 times sine square, which is sine square of alpha. Cosine square times cosine square, this will be cosine to the fourth of alpha. The resulting denominator will be the product. I will write first sine square of alpha, then cosine square of alpha, and this should be equal to the ratio 13/3. It's all algebra now, plus our knowledge of the so-called definition of the different functions. So simplifying this one, we cross multiply, right? So 3 multiplied by this quantity here, it is this. And the right hand side will be 13 times this sine square alpha cosine square of alpha. Right? We cross multiply, so we don't have any more denominator. What do you call this? Expanding 3 times this quantity here will be the, right? And 13 times sine square of alpha cosine square of alpha. We transpose this to the left, so this is now negative. So the right hand side will be just be simply equal to 0. Okay? Since the resulting equation contains a sine function and cosine function, but the cosine function actually overtake the sine function because the highest power of cosine is 4. So it's a must that we should convert all sine function to a cosine function. Okay? So if we try to simplify this one now, this should be 3 cosine to the 4th, right? We simplify this one. We place the coefficient 3. Then we replace sine square of alpha by the quantity. Sine square of alpha plus cosine square of alpha is 1. Therefore, sine square of alpha will be 1 minus cosine square. So we replace the sine square of alpha by the quantity 1 minus cosine square of alpha. Okay. This is minus 13. Okay. We rewrite first this cosine square of alpha. We do not replace this one. But we replace this sine square of alpha here by 1 minus cosine square of alpha. Then we expand. Right? So the function now after the substitution are all now in terms of the cosine function. Okay? What's next? The first expansion will be 3 cosine to the 4th of alpha. It is this. 3 times 1 will be 3. And 3 times negative cosine square of alpha will be negative 3 cosine square of alpha. The next one, negative 13 cosine square of alpha times 1. Negative and a positive will be negative. So this will be negative 13 cosine square of alpha. The last part will be a negative and a negative, right? So it will now be plus, but the coefficient should be 13. Plus, so this is plus 13. And the product of cosine square alpha times cosine square of alpha, that will be cosine to the 4th of alpha. And the right hand side should be equal to 0. Then try to combine similar terms again. This is 3 cosine square of alpha, or to the 4th alpha. This is 13 cosine to the 4th alpha. They are similar. So 13 plus 3, this will now be 16 cosine to the 4th of alpha. Okay. What's next? This is negative 3 cosine square of alpha. This is negative 13. They are similar. This negative, negative. So this should be negative 3, negative 13 will be negative 16 times cosine square of alpha. Okay. And the pure constant term will be plus 3. And this should be equal to 0. Then, this is actually with the power 4. This is square. But we could change this one into something like a quadratic equation. So this can be written as 16. We put this one as cosine square of alpha quantity square. Because cosine square of alpha to the 2nd power is actually cosine to the 4th of alpha. So this one here can be written as 16 cosine square of alpha quantity square minus 16 cosine square of alpha plus 3 equal to 0. So this is actually a trigonometry quadratic equation. Quadratic. in which the value of the unknown is not x, unluckily, it's a trigonometric equation, cosine square of alpha. Right? So it seems this is our x, originally on the algebraic equation. This is our x squared, and this is our x. Right? So in here, if this is trigonometric quadratic equation, the coefficient of the square term is actually 16. The coefficient of the linear thing is a negative 16. This is negative 16. And the pure constant term is 3. So solving for the unknown now, it is not x. It should be cosine square of alpha. Cosine square of alpha is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Substituting values, cosine square of alpha. We are solving for cosine square of alpha. It is not x. It's a trigonometric equation. It's a negative open quantity, negative 16, plus or minus. This should be b squared. There should be a negative thing inside. Anyway, we square it, it doesn't matter. Negative b squared minus 4 times the value a, which is 16, times the value of c, which is 3, all over 2 times 16. If we try to simplify this one, the result will be the square root of 64. And luckily, square root of 64 is actually a perfect square. So what will come out will be cosine square of alpha will be equal to 16 plus or minus the square root of 64 over 32. We use the plus or minus sign here because the overall sign inside the radical is a plus, and the square root of a plus real number is actually a plus and minus. So cosine square of alpha will be 16 plus or minus 8 all over 32. Since this is with the power 4, alpha should have 4 values. Right? Alpha number 1, 2, 3, 4. Right? So by using the positive sign here, cosine square of alpha will be 16 plus 8, that will be 24 over 32, by using the plus sign. Okay? Therefore, cosine square of alpha, 24 over 32 is 0.25. And to compute for alpha, we will take the square root of both sides. We raise both sides to the 1/2. Right? So these two here will cancel with this one. It will now just be simply cosine of alpha, the left hand side. And for the right hand side, since this is plus, okay, we will try again to take the square root of a positive real number. So what will come out will be plus or minus the square root of 0.75. Therefore, cosine of alpha, if we try to take the square root of 0.75, it is either plus or minus 0.866. 2 values, right? Because there are 4 possible values for alpha. Therefore, alpha now, if we try to compute for alpha, we must have to eliminate this cosine here. So we will take cosine to the minus 1 of both sides, meaning arc cosine. Cosine to the minus 1 of cosine of alpha will just be simply alpha. And this is equal to cosine to the minus 1 or arc cosine are the same. So the right hand side will be the arc cosine of plus or minus 0.866. And if you try to bring out your calculator, place plus or minus 0.866. What will come out will be plus or minus 30 degrees. So alpha number 1 is plus 30 degrees. And alpha number 2 will be negative 30 degrees. That is by using the positive sign. And by using the negative sign, cosine square of alpha will be equal to, from here, we use the negative sign. We are done with the plus, right? So it will become 16 minus 8. 16 minus 8 is 8 over 32. So cosine square of alpha, 8 over 32 is 0.25. Then again, try to take the square root of both sides. right? These two here will cancel with this. Cosine of alpha, the left hand side will be equal to the right hand side, it will be the square root of 0.25. Positive 0.25, a positive real number, and the square root of a positive real number is actually a plus or minus value. So this will become a plus or minus the square root of 0.25, or cosine of alpha will be plus or minus. Luckily, 0.25 is a perfect square. The square root will be a plus or minus 0.5. And to compute for alpha without the cosine, take the arc cosine to the minus 1 of both sides. So the arc cosine of alpha will be alpha. And for the right hand side, this is also same as arc cosine, right? The right hand side will be the arc cosine of the quantity plus or minus 0.5. And if you try to bring out your calculator, what will come out will be either a plus or minus 60 degrees. By using the positive sign, it is 60 degrees, and by using the negative sign, it is negative 60 degrees. So this is the second batch of answer. So meaning alpha number 3 will be plus 60 degrees, and alpha number 4 will be negative 60 degrees. So this is actually the solution of the given trigonometric equation. Okay, that's it, guys. I think this is more than good enough to illustrate the concept of how to solve a given trigonometric equation. Okay, this is Professor David J. De Los Reyes. Good morning from Los Angeles.